Hello. This is the second episode that we are doing today about this AI series. So this is episode 2. ep- Episode 2, and the name is Contextualizing Data with RAG. Actually, the RAG is a concept that I will explain going on. I mean, in the later stage of this video, I will explain RAG, what is RAG and all. And I have promised in the last video. If you remember that we have we have made local AI server, we have made replicate server, and we have done a lot of experiments. How to install it, how to take it from Hugging Face. From the Hugging Face that we are taking the models and all. So in that we have told that, I mean, we told that we are using Qwen 3. That's the model that now we are using. In fact, we are using one more that's embedding model. I'll explain you that. So at that time that we were just using the standard models from here and just installing on a local machine and explaining what is happening. Okay. Today we are actually doing some data contextualization, data preparation. I mean, in the later part of the video, the technical details, Hiram will explain that. But in the initial part, a few minutes, I will explain what is the data. I mean, how we are preparing data. What is the importance of preparing data? This type of things. Okay. So one thing that if you already know that there is a attention, that LLM models. Attention is all you need. The paper that's published by Toronto University and Google combined. So this paper, if you ever got a chance to work on mathematical papers and all, you know that this paper is the foundation for LLM. So just these are all basic things, but I just going through that because maybe few of you don't know what is LLM and all. Basically, entire AI system entire AI, machine learning, and all of these things. It's working on top of LLM. That's large language model, right? So it's just fundamental. So in the large language model, what it basically do, it's finding the next letter. For example, even you type large language or whatever, and ask ChatGPT to give what's the next word, it will give you that. It will give something like obvious things like President of America is, it will find the next word. So basically, large language model is all about finding the next word. Then next word. I mean, if it's, I'll show you on Gemini nowadays. I'm using Gemini, not ChatGPT. So I'll just recently we have. So here, if I ask Gemini something like, I'm not asking a question. I'm just making a statement. Okay, President of USA is, fill the blank. If I put it like that, it will give the next. Okay, so President of the USA is Donald Trump. Okay, what it does, it takes the most probable next word or name or whatever. Then based on that, it will take next like that. If I might draw, I'll just put it like this. There is something called transformers. If you know that concept, it's transformers. There are different type of transformers and all, but I'm just putting it here basically. So if you put one word here, This is very simplified concept, and it's so if you put something, a question here, who is the president, who is the, no, it's not like that. I'm just putting a president of USA, and it will assume it will take next word here and give it. Okay, then again it will come back to here. It will come back to here. What is that? It will come back to here and find the next word. Then again, after finding the next word, it will come. Then it's probably make a sentence or a paragraph, or it's like that. That's basically LLM. LLM basically it is finding the next word. That's just, you need to understand that. That's the next. You just find the next word, then next word, and so here it will be like, it found Donald Trump, then it's go on giving, he's currently serving as the 47. I mean, this is the way LLM works. What is the context that in our ERPNext prompt? I will explain. Just wait for another 5 minutes. Let me finish this concept. Okay, let me finish this concept, then we will go there. And if so, that's the easy question, but I am just asking some other question. Like, I'm not asking a question, I'm just giving a sentence. Question basically another form of the sentence to find next word. So I'm taking it something like, India is a big, okay, and I put a dot here and ask it to give fill with one word. Okay, it's so anyone, you all know what will be the obvious answer. That will be, India is a big country. It should be like that. Okay, so Gemini, it's actually filling, it's exactly like that. India is a big country, right? Okay, so if you don't have any context and if you just say India is a big, then it will say India is a big country, and it's asking for Python logic and all. Just don't care that, because I'm doing a lot of Python on this. That's why it's saying that. So ignore that part. Just look at this part. India is a big country. So if, let's say, if you are something like a climate research, you are doing climate research, and if you are typing this, maybe this country is not the answer you are looking for. So how you will do that? Let's say you add a prompt here, you add a context here. What is context? I'll just put the context here. I'll just put it like, climate change is a global problem. Okay, then I put same, India is a big, okay, and I ask them to fill with a word. What it will do? Okay, so India is a big contributor. It's saying India is a big contributor, or often it will say India is a great emitter, or sometime it will say India is a big polluter or whatever. But it will not say India is a big country, because the context changed. Now the context is climate change. It's a climate change. Okay, so like I will put another here. So I will say corruption. Dealing with corruption. I put another context. Dealing with corruption. India is a big. Okay. So what it will say? Let's see. Oh no. India. Okay, no. I changed the context. It didn't understand. Oh, I put corruption. Okay, corrupt. Sorry, that was the issue. Dealing with corruption, India is a big challenge. It says dealing with corruption, India is a big challenge. Okay, or it will say it's a big failure, or I mean, that's so. These are three contexts. I put three contexts, right? I put three contexts here, and all three is giving three different answers. First, if I put here, India is a big, then it will say country. Okay, and if I say in the context of climate change, India is a big emitter or polluter or whatever, and dealing with corruption, India is a big failure. Let's say it's like that. Okay, so you make it's just this you can say the question, and this you can say the prompt or a context. So here, so you are giving three different contexts and you are finding three different next word. So if you ask 10 words, it will give you 10. It will go on giving this. For example, if you put it, then it will keep on adding new words. If you are just asking for one word, it will give you one word. But if you are asking for 10 words, it will keep on adding, because I told you before, this like in a transformer, it will keep coming back and finding new words. That's how it works. Okay, now let's see how it works. Okay, so what AI does, it creates, just a moment. Okay, so what we are doing, it creates vectors. Okay, so what is vectors? It's just a number. I mean, there are many words and explanation like tokens and vectors and many things, but don't look at that. This I'm just explaining the concept. So each of these words, it's creating a vector. It's creating a number actually. So each will have a number. So I'll show you how number. I prepared this sheet for this. So there are many things, in the last episode we told you that there is 3 billion. So you can see it here on the Hugging Face. When you look at that, you can see 2 billion, 8 billion, 8 billion, 30 billion, like that. Okay, so here normally in a 30 billion, there will be 30 billion columns or 30 billion rows, whatever you bring. It's multi-dimensional. So you can assume that this is such a huge, I mean, very huge, beyond your imagination, a table. Okay, but right now what we will do, we will put here pizza. That's not in our question, but it will be there. Let's assume pizza, India, country, emitter, failure. There are so many things. So if somebody asks simply India, it qualifies it's a country. Okay, so if somebody say India is a big, it naturally come here 0.276, 0.008, 0.003 and 0.00. So if you add it all together, so it will be 0.287. That will be the largest. So it will naturally say, if somebody asks India is a big, it will give country. That's simple. Okay, so it's same like that. If you add India is a big and add climate with that, so if there is a climate, and you will see it here, emitter. emitter matching it is 0.380. So if you add it with India is a big and climate, so it's with climate it will be much bigger number. So basically what you are doing in adding India is a big without any context, it will give this country, and if you add the climate it will give emitter, and if you add corruption it will give 0.420 failure. Okay, and if it's, let's say, IT export, India has a very good score, that success score is, so if you put in the context of IT export it will give a success, so it will be like big number you see here. So and there are totals you don't need to consider in this point, but it's basically your questions are tokens, and the entire words in the world with 30 billion 40 billion, I heard Google is coming with 1 trillion, so it will be like 1 trillion records, 1 trillion vector values will be here, so it will match the nearest, the combination of as 3 words it will match with the 4th word, and then combination of 4th word it will match with the 5th word, it will go on like that. But in our context, in our ERP context, what happens, we also need to give context, because without context, without attention is the nearest one, so it's a word that's complicated. But if you are saying, let's say, I will directly go to something like, give me total number of our customers. This one, first of all, a LLM, a language model, cannot find how many customers you have. So we generally give either ORM or SQL. Okay, ORM or SQL. For the easiness of demonstration, I will just put SQL only here. Okay, and I will say give me SQL. Give me SQL for finding total number of customers. I just type it here on ChatGPT or any other model, Google Gemini. Okay, so if I give it that, what happens, it will see select count star as total customers from customers. This is the SQL. And as you are all working with ERPNext or any other ERPNext, you know this doesn't matter. It will not work, because our table name is not customers, the field name is not correct, nothing is correct here. Okay, so if you just execute this there will be it will return error. So what we need to do, we need to add a context here. Okay, so again I am doing it here. I will add it here for ERPNext. Okay, you will be lucky because Gemini and ChatGPT are nowadays, they are giving mostly correct table name here. Mostly correct table name. The reason is ERPNext is an open source software, and it on the GitHub it has all the details of all the tables and everything, so it easily finds it. Fair. Okay, that's the good part. So if you just add context, you get it for ERPNext. So this most probably will run it, and some complicated query also will run. For example, you just add the context for ERPNext, give me SQL for customer who bought most number of pens last month. Okay, so look at this. For ERPNext, it's a context is there, but you will find some issue here. That's what the major issue, that when you are building a chatbot for ERP. So this is, so you will get a query. I'll show you Gemini. This is the latest Gemini. I have paid, and I'm getting the latest. So it will improve in the future also. And this, you can see it here. The query is correct actually. Basically, I mean mostly it's correct. So you can see it. Tab sales invoice is correct. Okay, if you are working with that, and join tab sales invoice item is also correct. Okay, and it will find customer and it will give it. Okay, so this work, and this will work with the models, most of the models, the latest models that's available on Hugging Face. ChatGPT is one model. Most of the models, because they are scraping GitHub and they are giving that. So the next one, you will have another problem. Okay, now here also you have one problem, that I will say, this pen. Okay, this system doesn't know, I mean ChatGPT doesn't know what is pen. I mean, if you are running a query, this is like pen. I'll give another one. Give me a customer who bought most number of pens last month. No, that I will put it like this. Tell me, give me SQL for finding how many pens John bought last month. Okay. So here you see there are multiple issues here. First of all, it's saying customer John. Okay, but if you are working with ERPNext, the customer is not like that. It should be like item, customer code, customer name, etc. And John normally is not John. There will be a second name, there will be a third name or something like that. Okay, but the normal customer, normal user will type John. That's one issue. So you need to know which John. That's one thing. And this pen, this is not the pen, because the like query on item names of pen, it will not work in normal queries. So because this business inquiry, and you need to know what is the which brand and model and etc. Okay, so you when you are adding context, this is the context you are adding, right? No. So this is for ERPNext. This is the context you are adding. So when you are adding this context, you must give item code for consider item code is equal to ITM, then or 001 or something like that, and customer code is equal to T0034. Okay. So this context, if you give this context, you will get mostly a perfect one. So here they will add it customer correctly and the pen correctly, and the rest anyway it's fine. Rest is fine. So you will get a correct answer for the query. So how you will get this? How to add this in a context? Okay, and I will tell you one more thing. This is item master. So and the other case is we have custom field, and we have private apps. Custom fields and private app. There are custom fields, custom tables, custom fields, okay, and custom apps and private apps. Okay, these private apps we are not publishing on GitHub, and custom apps, custom field also, sometimes it is there but sometimes it's not, many of it is not there. So there is no way that ChatGPT or any other LLM models guess what are the fields, okay, or what are the apps, or what are the private apps, and what are the. So what it will do, for example, I will give you one of our for ERPNext Zatka e-invoicing module. I'll put it that Saudi Arabian e-invoicing. This is actually a real case that we are dealing. Invoicing app. Give me SQL finding submissions with warnings. It's a real case actually. What happens when you are submitting e-invoices? Some of the invoices will give you warnings from the government servers. The API will return a warning. So this is an app that we publish this app. This is actually on the GitHub, so you may get answer correctly. It's a public app that we have published, but there are private apps. But let's see. So here, this app. Oh, this is actually a public app, so we have published it, so it is there. Okay, but imagine that you are using an app that's not published on GitHub, so they don't know the table name, okay, or they don't know. I mean, they don't even know what is this, what they are talking about, what is submissions, what is warning. I mean, there is no clue because it's a private app, right? So in this case, there is this. We need, in the context, we need to add it like. So how you will add the context here? So invoicing field name is something, table name is, right? Table name is something like tab Zatka submission, and field name is something like custom success. Then you give that, then it will give you correct one. Okay, so here it will give you correct one. So the table name I give here, this message I give here, and the context also I give here, then it will give you a correct SQL. Okay, this is the one of the hardest thing that we have faced, because initially I have explained in the blog that we have published. A lot of you are commented on that. A lot of you send me messages, clarifications and all. Some of you are asking live webinar to explain that and all. It is there here, so you can see that here we have published it. So here if you have missed it, so it's in the blogs in our this building an age, this one. So a journey through failed experiments. So we have explained that what are the challenges and how we faced it. I mean, so every time, because if these are all not correct, there is no way that you are going to get the accurate result. So what all we discussed now, we need, okay, I'll say as a context or a prompt, what we need to, or a prompt to, with the question, what we need to pass, customer or item code, etc. Okay, this is, we can categorize as master table data. Okay, then what we need to do, field name, table names, table names, field names. So if you put table name as field name, you may have joins also, because how to connect between that. Okay. So there are multiple contexts that we need to supply to get accurate result. Otherwise, you will never get accurate result. So this is what. Otherwise, it will be like our old question that you are asking. India is a big, so it will always give big. That's country. So it will not give. If you are a climate researcher, also you will not get. So you need to add the context. So this is what the context means. So here, customer item code. Okay. So normally, what people ask, if you are adding master data in the context, why you are not adding transaction data, like sales invoice or accounting ledger, etc. If you pass that, then you will get more accurate result, right? No, it's not. The reason is these data are normally, for a business, it will come in millions. It's a huge record, and there is no way other than SQL or ORM to get the sum, the details, the maximum, minimum, etc. Other than SQL or ORM. Maybe in the future there may be some other things comes. But right now, for transaction data, you need to have SQL to run SQL or ORM. So basically, what you need to do, you need to give context with master table, tables, field names, and joins, and probably you need to add some examples. That's also a good option. Okay. We haven't added that, but I just was thinking like that. So these are the things. If you add these things, then you will get more accurate data, and each time that you are adding more and more things, that you will get, I mean, if you add more context, then you will get a more accurate answer. That is the reason that we have dropped other plans, like using ChatGPT. I mean, also I will tell you this. Let's say if you want to use ChatGPT for this, or Google prompt or something like that. So the thing is, there is some limitations to sending you cannot fine tune ChatGPT or Gemini or something. It's already fine tuned one. You cannot add data. You can set context. I will explain that. But even then, you cannot improve the, I mean, in the specific context. Many contexts you cannot improve data because, for example, we were discussing climate change before. So if you have so much personal data about the climate in India and the geography and etc., so you cannot totally depend on Gemini or AI. You need to add that document as a context and get the answers. I'm not talking about only about ERP, but if you are a climate researcher, or if you are a student of geography, or a student of mathematics or fiber optics or whatever, so if you are doing that, then you need to add context with the data that you have personally with you, as PDF or SQL or something like that. So that's why we are using our own models and our own contextual. So on that point, we are coming to this something called RAG. Okay, so it is actually retrieval augmentation generation or some whatever. I'm not good at that, but okay. So this is retrieval augmentation. It's actually what it say. Retrieval means retrieve master table data, table name, field name, or climate change, geography, whatever that you have in your local server. Augmentation means you are augmenting, you are enhancing the original with this data, and generation means you are generating from the LLM model. So this RAG, let now on the let's discuss how we are doing RAG in this ERPNext context. So let's do that now. Okay, on RAG. So okay, let's do that. So on the RAG, what we do on RAG, it's actually before I come into that, I will, because it's better I say, we are using two AI models here. Okay, one is embedding model, and the second one is LLM model. LLM, or you can say generative model. I don't want to go to that all junks. Just I'm saying that we are using two. Okay, you can also use, and there are many of it here. On if you go to Hugging Face, you can see many of these models. Many of it are embedding models. There are, you can see many embedding models out there. So what we are using here as an embedding model, I will come and explain which embedding what is embedding model. So we are using something called nomic AI. Okay, so this embedding model we are using nomic AI. This is the embedding model, and this one I show you Qwen 3. These are the two models. I mean, what is the difference? LLM, I told you, LLM has billions of records, probably trillions of records in the coming months, and a lot of vectors and tokens and everything. All of it designed entire internet out there. So whatever question you ask, it's supposed to give you answers, and it will create SQL and all. So this one we use for to create SQL and finding anything on. I mean, it use entire internet and the whatever on the model, like billions of vectors on the models to generate the answer what you want. This is the LLM tool, and the embedding model. This was today's our topic. We will come back to LLM how we are using later on the another episode on the embedding model. The embedding model, it's actually, as its name suggests, it's just for embedding. So that's it. It's for embedding. Okay. So what is embedding? Embedding means we discussed some data before, right? So it's table names, field names, joins, and then master tables. Okay, these are, I mean, these are small data. Table names are small data. Maybe I think 300 400 tables are there, and field names, if you multiply 300 into 50, that's not a big data. Joins, that very little. Master table may be very big, because some companies have customers of 10,000 20,000 customers, and items, so many items, like hundreds of thousands of items and all. But still, you can say it's small data. So it's not like in a billions, trillions and all. The data inside embedding model, normally it we will be able to run it on our own server, on ERPNext server, or on another server, third server, we can run it. So this is a small operation. This one LLM is big, but still we are using our own AI server. We are using it. I have explained last one, and we will do it how to fine tune LLM in the future episodes. So here we are just explaining RAG. Okay. So in the RAG, what exactly it's doing? When you say embedding, what it does, it has multiple steps. So it does multiple things. Okay, the embedding means, first of all, it doing chunking. Chunking means, if it's not supposed to handle very huge data, so we are chunking it into different tables, like tables, um, customer, customer master, or something like custom app fields, etc., etc. We are chunking it into small files. The data, we are chunking it into small files. That's the first step, the step number one for embedding. And step number two is it's actually retrieval. Okay, so when you say chunking, okay, what happens here in this, it's mainly we are making it into a data scheme actually. So it's a general, what you need to do, it actually, the word that we are using is generate cards, different cards, and each value will have its own vector. So it will be like, if you have several customers, each customer will have a value, or I mean a number. Same like this one. The local model also, I mean the embedding. So basically, if you are having, if you are having this LLM, it already come with all the vectors here, it already come with that. Okay, so everything is already there. If you are already using LLM we are using, so it will have. But in the embedding model, nomic AI and all, it doesn't have all this data. There is no data, so we are filling the data. So there is a process for that at the time of chunking and embedding in the vector store. So what we do, where is that? So after chunking into different files, we are embedding into vector store. So there is something called vector store. So vector store is nothing but a file. It's a file same like this. It will look same like this. If you imagine, uh, it will be binary, but still. So that's why I said, if you imagine, if you actually open it, it will not be like that, because it's in binary. So this one, for each of these tables, customer matter, customer app fields, and the master data, you will have a number, a vector here. Okay, so once you embed it, it's making it into a vector store. And the vector store is the vector store we are using, not only we, everyone using FAISS vector store. So this vector store, it's actually Facebook something, I don't remember the full form, but FAISS, this is the vector store. It's actually, F stands for Facebook. So it's a store algorithm that's designed by Facebook, and it's very popular. Everyone using that, not only us. So here we chunked, and here embedding into vector store. Basically all the tables. For example, tomato, they convert into 0 point something like that. A pen, they will convert into it's not exactly like that. And the names like John Matthew, they will convert into, it's like whatever we are giving in this chunk, this embedding steps, actually how we are embedding it, Aaron will show you that in technically, and we have uploaded it into GitHub also. It's an open source, you can see the code also. So this one we tomato, okay, tomato or pen or John or Matthew, anything we will put it into vector store. Okay, so this vector store. Then after that there is something called retrieval. Retrieval is retrieval. It's actually, you can say, semantic search. Okay, what is semantic search is, if we are putting something, a query like find last month invoice or something like that, invoice total or anything, we already have table name, field name, customer master, item master, everything here, and the chunk, everything here in the chunk. And so when we are doing semantic search on this, let's say this is the search string. The search string is, let's say, give me total sale of tomato last month, something like that. So to generate this data, like the item name will come from here, the total sale field and tables come from here, or if it's a something like custom app like our SATCA or something, give me e-invoice warnings. So this is a custom app, so it will take from the custom app fields and it will club it. So what it will do, let's say, so if this is the query, this matrix will have many numbers and it will calculate a number for these lines. So let's say we have done it here exactly. This is why at the beginning I went through these steps, okay, to show you how it works actually. So here, if instead of this India and all, we will put give me e-invoice, give me e-invoice warning, something like that. So this will have a number, a token, okay. So here you will have field name. It's not exactly like that, but I am just giving you the table name, then master data, etc. So it will calculate the nearest number for this question in multiple chunks. This is not exactly one chunk because it may need different. It may need table name, it may need field name, it may item master, item code, customer code, etc. So it may need many things. So it will, this like this, there will be multiple chunks. So this chunk you can call it is a tab field names, okay. There will be another chunk that is table names, there will be another one customer chunks, there will be another item chunks, there will be custom chunk, custom data chunk, etc. So whenever it's get a query, it will take the nearest number from the nearest, I mean from all chunks basically. So it may need from multiple chunks. If it's need from only one chunk, or it will take from that only, but it will be taking the nearest number. So when you are taking the nearest number, that is called semantic search. So this search is actually not a text-to-text search. It will create a token with the input and it will find the nearest vector as a number and it will return that number, okay. That number we are converting it into a prompt. So what it will happen, when if this is our query, it will add a context like give me this, if this is the, so it is actually called augmenting, okay. Augment augmenting means, in English it's enhancing or adding up or something like that, right? So I'm not good at English, but let's say it's like that. So augmenting means you have this query, give me total sales. So you augment it with field names, masters, uh, item names, table names, joins, all you have returned from the nearest vector on this query. Okay, is it complicated? I just maybe, so maybe we may need a live webinar, so we'll discuss further. But here, give me total number of sales, total sales, field names, item names, table name, joins. So we are augmenting this much information with the question and sending it for the retrieval. Okay, so we augmented, and then it's called generation. What is that? So it is now RAG, right? The last step. Generation means, okay, this is augmenting, and we are sending this with SQL. So this is, we are sending to SQL, and you remember we have an LLM model. By the way, these are all, don't forget, these are embedding models. Whatever we have done it on an embedding model, this is actually an LLM model. So we are sending this everything to Qwen. Okay, so then same like in the beginning, what I told you. So if you want different context for India is a big country. India, climate change, India is a big event dealing. So you need to add this part through embedding Nomic AI embedding model. So one final question I will answer here. Why we need this? Why we need all of this? The reason is this field names and the master and everything are so big in a company, very big. So you cannot pass everything to an LLM. You need to take the context. I mean, when you are asking to give total sales of this field name, item name, table name, joins, etc., you need to take from the vector, this FAS vector store, only the required one. So it will be like maximum 10 or 20 words that you can attach it as a prompt to the LLM. You cannot attach everything to the LLM. So that's the all of this actually means. Okay, so I think that covered the concept of our session, that is contextualizing data through RAG. But we have published it, and my colleague Irene is here. She will explain how we are doing all these steps, like how we are doing chunking, how we are doing embedding, semantic search, augmenting, and generation. Then after that, we have so many things to do, like LangChain, LangGraph, and SQL running and return it. There are so many things that we are doing in the same. So we will cover it in next episode. As we have told, maybe we need more episode than we initially discussed. But anyway, so you can see the code in our GitHub, and Hiren will explain. Okay, Hiren, you can start.
RAG. What is RAG? Basically, RAG is nothing, it's just retrieval augmented generation. retrieval. A stands for augmented. And G stands for generation. G stands for generation. So retrieval, augmented, generation. And here in retrieval we use multiple things, like we use a schema. In case of retrieval we use multiple things. One is schema, the other one is master data, and the other one is model. Schema and embedding model and master data. I think all these are clear. Augmented, as Farooq already described, augmented means we just add the output that we get from this embedding model, that schema context, with better in a proper prompt, and we pass that augmented prompt to the generating model. Here in generation part we use a model, that is the generation model, as already discussed. It's Qwen 3 model that we use for generating the SQL. In generation we are using LLM, which is Qwen 3 model, and which actually gives you the SQL. Okay, this augmented prompt, here through augmentation step we actually generate the prompt for generating the SQL, and inside this augmented prompt we add the output that we get from this retrieval stage. It's nothing but the schema context. We add that directly to this augmented prompt. Now I think you got that idea, as already said by Farooq. Now I will explain how we pass the schema, how we pass the master data to this embedding model, in which format. Since embedding model is a model, and this model does not understand the text format directly, that means we need to convert both the schema and both the master data into vectors. Vectors means number. So before we convert these into some vector stores, all of that, we have to add some better context, better details inside this master data. Inside the schema. I will show the format how we save the schema, and which all details we add in the schema. In the schema we add chunks. We store table chunks, field chunks, and join chunks. We add these details inside the schema, and along with these chunks, table chunk means the doc type, like example employee doc type, and field chunks means the fields that comes under the employee doc type, like name, employee ID, etc., posting date, etc. And in join chunks it comes the fields that have the link type. For example, inside the employee doc type we have a field called gender, which is actually a link type, which actually maps to gender.name, gender doc type, right, into the ID of the gender doc type. So the schema composed of these details: table chunks, field chunks, and join chunks. Now I will show you how we store the schema. This is the schema. You see the table name is there. We add synonyms and we provide a description which describe the details of employee doc type, the field chunks, name, type, role, description about the field chunk, primary key for employee record. We add these details to help the model to get a better context of our ERP domain. or our own specific schema. In order to help the model to understand our schema, we need to add better details. If you add better details with the description, all of that, it can help the model to give you the better output. And inside, you can see it here, join hint. This is actually, as I said, it's a link field. So gender is a link field and it maps to gender doc type. So we are passing the join chunks too. Also we mentioned the options in order to get the exact option values names. So this is what a schema look like. It's not like the row DB schema, which stores the only the tables and fields and its types. It does not store the description, or it does not store joins, all of that. So we collected the doc types and fields, their specific fields, and collected the joins separately, and we stored inside the schema file. So I think you got the concept. Now we convert the schema, this full schema, we convert it into vectors. Each and every we stored this item in a vector format, we stored these each and every items in a number format, all of that in a number format. Only then model can give you the right thing, because model only understand numbers. It does not understand the it does not understand what it does not understand the text directly. So we have to convert these things into numbers. So that's what we are doing with the FIAS vectors to creation. FIAS, Facebook AI similarity search space, which we use for vector storage, FIAS vector store. And as I said, we convert these things, the table chunks and field chunks and employee chunks, into vector format, where each and every items in these things are converted into numbers like this. Suppose table employee can be stored like something like numbers, etc. And similarly field like name can be stored like another list of numbers, etc. And similarly join chunk, here gender is a join chunk, right? So gender would be saved as a list of numbers, etc. So this is what FIAS vector storage means. It will convert this schema into a vector format like this. Similarly, this master data, I will show you the sample of our master data. We convert the master data into a FIAS vector store like this, but each of the items in this master data will have different vector formats. Okay, this is the sample master data, this is the table name, and this is a specific value in that table, and the field that is used to filter the table value. So master data, as we already explained, the reason why we are keeping a master data is to get the exact values of the master tables. Otherwise, whenever user mentions any specific identifiers or names in the user question, the model cannot hallucinate. Other than if we pass a master data with the specific values and all identifiers, all of that model can check onto this and can return the right one as per our records. So that's why we keep a master data. I think that part is clear. As we convert the schema into a vector store, we similarly do the same strategy for master data, where we convert master data into a FIAS vector store, and then we pass both these vector store into this embedding model. Embedding model will look onto that embedding store, and it finally gives us the data. So I'm not going to explain all of the technical side now. We will be uploading our next episodes, where we will cover the technical parts, how we convert the schema to FIAS vector store, how we convert master data to FIAS vector store, and how we map these vectors back to the text format, all of that. As you know, just for the case of understanding all of that before going to the technical session, let me give you a small idea. When a user types a question like what is the status of the sales invoice, or what is the status of the invoice invoice of the customer. No. What is the status of the invoice for William Taylor? Okay, now let me type it with some mistakes. William Taylor. Okay, suppose if the user types this question, what is the status of the invoice William Taylor? Now you see the we directly pass. Okay, one second, I am not used with this Excalibur row, so that's why I am having such issue. So yeah, so now I will pass this question directly to the embedding model. Okay, so as I said, we already passed the schema. We pass the schema, we also pass the master data, right? We pass the master data. Okay, we pass the schema to the model. But before passing the schema, which is in the text format, okay, you see this is in the text format. Before passing it directly in the text format to the embedding model, we convert the text formatted schema into a number format, which we store in the form of FIAS vector store, because embedding models does not understand the text, they only understand the number format. So embedding model will check on to this numbers records and it will produce numbers. You need to make sure that, you need to understand that it will check on to that FIAS vector store and it will give us the numbers, not the text. So these numbers which are in the vector format like this, or each and every numbers, many numbers, it will give out many numbers. Maybe this number maps to the doc type name, and doc type name like employee or customer or anything, and the second number would be something else which can be mapping to some fields like name or posting date or anything, and next number can be something like this, any numbers, because each of the numbers would be unique. It depends, it actually refers to the specific data as per the record, so it would be different, each of them would be unique. This would be mapping to any join field, and or another number would be any other number, etc. That would be mapping to any master value, like as here we mentioned William Taylor. As in the master data we can check if there is any William Taylor. No, William Taylor is not there, so model will be returning this record, right? The most similar one. So model will return the vector format of this specific record. I think you are getting that. So yeah, so in order to convert these things back to their real text format like employee, posting date, join field, master value, all of that, we have a separate method that I will be explaining that technical step one by one in our coming videos, coming episode. So for understanding, I will say we convert these things back to their original text format with the help of a mapping store. Okay, we convert these vectors back to their original form, that means their text format. As I said, this number, it's mapping to which one? Okay, this number can be mapping to tab sales invoice, and the second number might be mapping to what? Status, and the third number, status of invoice for, yeah, there won't be any join field for this, but there would be a master data because the user mentioning a name of a master table. Here master table can be customer William Taylor, so we have to, the model will be returning that specific value too. Okay, let's imagine William Taylor is a record in this customer record. Then the model will return the text format of that specific record. Then finally, now we have the schema context and master context, right? We have both the schema, which are the schema data from here, sales invoice and status, and which is the master data, this one William Taylor. Now finally we pass this for augmented generation. That means we generate the prompt with these details. The next important step is augmented generation. Augmentation means we will be generating a prompt with the schema context. These details we with these details we will generate a prompt by passing the schema context and the user question. So augmentation means we pass a prompt. Uh, we ask the Qwen prompt to which model, LLM here is Qwen 3. Okay, prompt would be like this: generate SQL for the user question. We pass the user question. As per the user question, we just copy that thing, we pass it here, and we pass the schema context. We pass the schema context. And then now generate SQL. Okay, so after that the next step is what? The next step is the generation step. We pass this this augmented prompt directly to the next model, which is the LLM Qwen 3 model. Okay, now the next stage is generating the SQL with this augmented prompt. We pass it to the SQL model, that is SQL LLM. Pass it to the LLM, which is Qwen 3 model here. Now with this prompt and with the schema context, now the model have access to the original records as per our data, and finally the model can generate what? SQL from this augmented prompt. It gives us the SQL, which would look like this. Select status from tab employee where name is equal to, okay, where customer name is equal to William Taylor. I think one more field is needed here. I forgot to mention that, customer name. Okay, now finally we got this SQL and we execute SQL, and we get a result in the format of dictionaries and or list. So like this, status pending, something like that. But we just convert this formatted output, we just convert this output into a better friendly format with the help of the same model, same Qwen 3 model. But we don't pass this prompt at that time. We pass a prompt where we will send this outcome. And we also pass the user question, which is this one: what is the status of the sales invoice? Let me mention that too. We again call the LLM, which is Qwen 3. For what purpose? For rewriting the output to a friendly format. To rewrite output to friendly format. Okay, spelling mistakes would be there because I'm typing fast, sorry for that. Now yeah, finally we will get output which would be in a better good format like this: the status of the sales invoice for customer William Taylor is what? Pending. So this would be the final, this is the overall flow, and we have different technical code explanation for this complete flow. We will be uploading the coming episodes, we will explain that there. I think you understood the concept. First of all, we have to prepare our schema. For that we have to pass the table chunks, field chunks and join chunks. Similarly, the master data, we have to add each and every master values of customer, item. Wherever we have to use the master values like identifier, employee names, customer names, all of that we keep a record for master data. We have a schema, enriched schema version with a description, details, all of that. These two we already uploaded these things in our GitHub, you can refer there. And see, we convert these things to a vector store, both the schema and the master vector format, master data into a vector format. We pass this vector format to the embedding model. We pass this embedding model. Embedding model will give output also in the vector format. We convert these things back to a text format like this using a doc store mapping. So I will explain that here. So as you know, we have the vector format now. Model output, model given this vector format. Now we convert that back into a text format like this. Once we get the vector format, we already keep a doc store for mapping. I will explain. We have a doc store. It's a storage which maps the each and every vectors to their respective text format. Whenever we store these things in a FIAS vector store, like let me show you that too. FIAS vector store would be a storage um, where we will have multiple vector formats like etc. FIAS vector store will have multiple vectors, and each and every vectors would have their specific identifier. For example, 0 would be mapping to the specific vector, and similarly the next number 1 would be mapping to any other vector like something like that, anything. So we will check the specific identifier, unique identifier for each and every vectors from this vector store. Suppose if 0 is the okay, so see, we have a FIAS vector store where each and every vectors would be mapping to their specific identifier, and inside the doc store we map this identifier to their real text format. Suppose if 0 is the identifier for this specific vector format, then we in the doc store we do what, we give the text format for that specific vector format like tab employee or anything. And if this vector format is mapping to any field, then we mention that one as posting date or something like that. I think you understood that thing. So from here itself we can directly map to their respective text format, like that 0 pointing to this and 1 pointing to the specific field. Like this we map the vectors into their real text format. This is how we do it here too. Here we convert these vectors to their real text format with the help of a doc store for mapping their identifier to their real text format. So these things I will explain in the technical episodes where we will explain how we are preparing doc store, how we prepare the FIAS vector store, and how we train our embedding model, how the model understand your specific schema. Whenever custom tables or custom fields come, the model has to learn all these things, how we teach the model, all of that. I think the concept and the steps and what is a RAG, this whole pipeline is what RAG it is, because here we are retrieving from the schema and here we are doing augmentation. That means we are giving a prompt to the LLM by the context we retrieved from the retrieval stage, and augmentation. Throughout this augmentation we prepare the augmented data, augmented prompt, and finally we send to the LLM model. And this is where we are doing the generation part, this stage, generation, that is RAG, retrieval augmented generation. Finally we will get an output in a friendly format. So I think the concept is clear. So how we create the FIAS vector store, how we create the doc store, I'm going to explain that now. We are using Colab because Colab gives us better performing GPUs, and we are using the Colab Pro version with the different GPU containers, because when you train your model you cannot run it on your local computer because CPU may take so much time and it would be so slow, take hours and hours to train your model. But with a proper GPU, like different resources they are providing, with a proper GPU container you can run your model fastly. So this is the code that we used for creating our vector store. We pass both the schema, the enriched schema and the master data. Entity actually refers to the master data, and we used our fine-tuned model. Fine-tuning means training your model. Every time you train your model, you save it to your own specific folders or anywhere according to your wish. Then you need to pass it here in the embed model name, and using this fine-tuned model we convert that our specific schema or master data into their own FIAS vector store. Okay, and this is the code we are using for it. We gave, for mentioning the table, we gave prefixes like table description, notes, all of that before the exact table name and like that. And similarly for options, for fields, for joins, all of that, we convert each and every tables, fields, joins, everything into vectors. Once we and this is where we pass our embedding model, and we pass our data, both the schema data and the FIAS, both the schema data and the master data. Once we run this code, we will get our files saved to their respective folders. Entity FIAS saved to this one. Entity FIAS means the master data, and schema FIAS refers to our schema, enriched schema. Now we created our FIAS vector store, and the next step we need to do is we have to create the doc store. As mentioned, we need a mapping from the FIAS vector store to their original text format. That's why we are keeping a doc store, in order to identify whichever vectors maps to their text format. So now the next step is creating your doc store. Now you pass your FIAS vector stores folder. This is where I store my FIAS vector stores. Now I am running this code. We load the schema cards and master data cards, and here we pass our model name, fine-tuned model name. We pass it as the embedding model, and then we run this. Once we run this, we will successfully, our doc store would be created. We create separate doc stores for both the schema FIAS vector store and the entity FIAS vector store. Now once we generated our doc store, the next step is to test our model. Every time when you train your model with your training data set, in the coming episodes we will explain how we prepare our training data set, how we train the model. We generate separate episodes for each and every topic. Now once after completing each and every training, you need to use the trained version of that model to generate the FIAS vector store and to generate the doc store. Now so I think the concept is clear. What is a FIAS vector store, why we use doc store, and once we generate these things, we call the embedding model. This embedding model use these stores, FIAS vector store and of schema and FIAS vector store of master data. Model use these two things for generating what? For generating the SQL. Now finally, embedding model gives us the context. Once we get the schema context, same thing, schema context, we generate the prompt. After generating, that is augmentation, we generate the prompt, we send to the model, all of that. I am not repeating all these things. I think you understood the concept. I have shown you the how we generate the vector store and how we generate the doc store. If you have any doubts regarding this specific episode, you can just comment below, or you can ask at support at erpgulf.com. Thank you for watching this video.